How could we implement curve fitting? Consider endpoints in the XY plane that represent a collection of data, and you want to find a polynomial function of degree n minus 1. So here there is a relation between the number of points available or given and the degree of the equation, the degree of the polynomial function. So the degree should be n minus 1, and the number of points here is n. So in this graph illustrated here, we have 3 points. So the polynomial function would be in which degree? It would be 3 minus 1 degree. That means second degree polynomial function. So second degree polynomial function means we have 3 terms in the function. So the general form of the equation of the polynomial function, we have here b of x equal a naught. This is the free term without any variable, and a1x plus a2x plus till a n minus 1 multiplied by x n minus 1. This is the general form for writing a polynomial function. You will find out that if we have here 3 terms, 3 points, so the equation would be 3 terms. That's why the polynomial function should end with n minus 1. This procedure is called polynomial curve fitting, to get an equation that represents the curve. When all x coordinates of the points are distinct means they are different, there is precisely one polynomial function of degree n minus 1 or less. So the main point here, I could have one polynomial function or less that fits the endpoints. We could have n minus 1 or less. Okay? So if we have here three points, I might have a polynomial function of second degree or first degree, or that's it. Okay, let me show you the procedures that must be followed while getting the function of a curve. Here, to get or to solve for the coefficients of the polynomial function, first you need to substitute each of the n points into the polynomial function. So I'm gonna substitute the n points here in each term. And then obtain n linear equations in n variables. Okay, those would be the required, those are required points, or required unknowns. You can write down here unknowns. And then finally solve the system of equations to get the values of a naught, a1 till a n minus 1. So solving the system of equations here, either by matrices or Cramer's rule, or using Gaussian elimination or Gaussian-Jordan elimination. Here we have an an example, determine the polynomial bx, b of x equal a naught plus a1x plus a2x power 2, whose graph passes through the points 1, 4, 2, 0, 3, 12. So we have here 3 points, and we have here 3 terms. So it is a polynomial function, and the steps would be substituting with the x values. So we have here 3x. Here we can write down here the values of x. I'm going to substitute with 1, 2, and 3. The values of b of x would be 4, 0, and 12. So I'm going to write down the first equation. B of 1 equal a naught plus a1 of 1 plus a2 of 1 squared. Here, b of 1, which is the first value, b of 1 would equal 4, and b of 2 would equal 0, and b of 3 would equal 12. So here we can substitute with 4. And then the next one would be a naught plus 2 a1 plus 4 a2 equals 0. And the third one would be 12 equal a naught plus 3 a1 plus 9 a2. So we have here 3 equations: equation 1, equation 2, equation 3. So we can go back to the first 2 lectures, review them in order to be able to solve the system of linear equations here. We can use any of the methods explained before. So finally, here a naught equal 24, and we have here a1 equal negative 28, and we have a2 equal 8. So we can write down the equation. Finally, here b of x equal 24 minus 28x plus 8x squared. This is the polynomial function of the graph. Okay, yeah, here are the answers. You can now try out one problem in the worksheet related to the curve fitting. Here we have another application related to the curve fitting. The table shows the net profits in millions of dollars for Microsoft from 2007 till 2014. We have the year and the profit in the corresponding year. Okay, here. And so on. These are the profits during the interval from 2007 till 2014. The question here is, set up a system of equations to fit the data for the years 2007 and 8 and 9 till 2010 to cubic model. Cubic model means that the equation, the polynomial function or the polynomial equation should be with the maximum x power 3. Here, I'm going to stop the data here. This is the first required point here to solve for a polynomial function for these data only. 4 points. So we have n equal 4. So the polynomial function would be up to the third degree or less. So the polynomial function would be b of x equal a naught plus a1 x plus a2 x squared plus a3 x power 3. We have here 4 terms as 4 points, and the degree is n minus 1, which is less than the number of points. So I'm going to substitute with the values. Here we can consider the year as x and the net profit as b of x. However, here the numbers in the x are large. The numbers or the x values are large. So in this case, we use some sort of translation to make the problem somehow simpler to be manipulated. Here I'm going to use the following. I'm going to say let z equal x minus 2000. So the x values would be translated to the following. Z equal the first 2007 minus 2000, which is 7. And then we have 8 and 9 and 10. 7 has a profit of 14,065, and we have here 17,681, and we have here 14,569, and we have here 18,760. So we can manipulate those or these numbers simply without having extra or large numbers. So we can write down here 4 equations in 4 variables, and then by solving the equation, you are going to have x1 equal negative 137, 8 to 35. x2 would equal 100, 1459 over 2, and x3 negative 59488, and x4 would equal 4677 divided by 2. Those here, these values are the values of the x. I should write here instead of this x a naught a1 sorry and 8 2 and finally 8 3. So these are the values of the constants here, constants. So I can rewrite the equation using the coefficients here, and I can solve for b, which is pretty easy here. Solve the system, so I can solve it with any methods like Cramer's rule, matrices, or Gaussian elimination. Does the solution produce a reasonable model for determining net profits after 2010? So I'm gonna, after substituting with the values here in the equations, I'm gonna substitute with 2011 here. So the new z new equal 2011 minus 2000, which is 11. So I'm gonna substitute with z as with 11, then getting b of z. So the new equation would be b of z equal a naught, this is b a naught only, plus a1 z plus a2 z squared plus a3 z power 3. So this is the equation that should be used to solve part B. So I'm going to use here the values, it's already calculated, and then I'm going to substitute with 11 here to get the new here. Yeah, it's already no z here. So you are going to get the value of z, and compare it with what is here, the profit. If there is a relation between them, the difference between them is large. So the question is, does the solution produce a reasonable model for determining net profits? You will find that the value calculated here is somehow very near to the actual value here. That means the mathematical model is not precisely presenting the real life. The actual model, or the calculated model, or the polynomial function is slightly, there would be slight difference between what is in the actual real life, and the calculated model. That's normal in engineering, that the points or the data calculated or gathered from sensors, when I want to represent these data using an equation, so the new calculated one will be different than the actual measured data. This is for part A, and I'm gonna complete part B in the lecture, which will be about solving network problems during the lectures. I hope the topic is interesting and you can solve the worksheet by yourself, and you can contact me if you have any questions. Thank you.